microfarad. So this is the value of CF. So CF is nothing but the 0.1 microfarad. And last step is nothing but the R compensating, or that is R1 parallel to RF. So we know the value of R1. R1 is 106.1 and this is nothing but the 1.06 10 to the power 3. So just take the parallel combination, it will be 96.44. So R compensating 96.44 ohms. So this is what the value of R compensating. So complete design, after calculating all these values, that is R1, C1, then RF, CF and R compensating, after that we have to draw the complete circuit diagram of differentiator with its value, that is like capacitor CF is equals to 0.1 microfarad, RF is equals to 1.06 K, C1 is 1 microfarad, R1 is 106.1 and R compensating, its value is 96.44 ohm. So this is what the final solution of the problem. So this is nothing but a differentiator circuit. So this is all about the differentiator circuit. So next step, so this is what the first problem. Now is some problem or problem related to the differentiator. It may ask that after designing a differentiator we have to calculate or we have to draw the output waveform for some time, some inputs, that is if the sine wave of 1 volt of 100 Hz, a sine wave of 2 volt of 2 volt with 1 kilohertz frequency is given as an input to the differentiator, what is the output? So that time we have to remember that formula. Now what is the formula? Formula is nothing but the VO. VO is equals to minus RF CM, RF into C1 with differentiation of input to differentiator of input. So this is nothing but a generalized and this is nothing but a minor. So this is nothing but a generalized formula for the output of a differentiator. That time when such a type of problem is asked, that is draw the output waveform for a input of sine wave, cos wave or square wave, that time we have to calculate the external value, that is gain value RF into C1 and differentiator input with respect to time. If sine wave is differentiator, so d dt of sine, whatever is the 2 pi ft वगैरह वगैरह जो भी आपके पास अवेलेबल रहेगा साइन वेव स्क्वायर वेव, that we have to differentiator and we have to calculate the value for 2 to 3 values. For that we may go for the problems that is related to that in next lecture, but in this lecture I want to clarify that output voltage we have to calculate likewise. We have to calculate the gain and then whatever is the input is given, that we have to differentiate with respect to time. So that for that we have to draw the output waveform. Now for example, if we take some signal, that is if we are providing sine wave, the generalized structure of the sine wave, that is sine wave, if we are providing a sine wave, it may the differentiation of the sine wave, we are not talking about the amplitude value, we just talk about the shape of the waveforms. If we are providing a sine wave, a differentiation of sine wave is nothing but the cos wave. So we get the cos wave like this. If we are providing, you may go for that, you just take this value, we take this value, we take this value, we take this value and we take this value. Differentiation of this sinusoidal wave for t is equals to 0, t is equals to 90 degree, t is equals to 180, or we can say t by 2, t by 4, t by 2, t by 3, t by 3, t by 4, this is t by 2, this is t by 4, this is t is equals to 0 and this is nothing but the t is nothing but the, this is t1 period. So we have to take this value. So for each value from t is equal to 0 to t, we have to calculate the output voltage, that is VO. And then we have to draw this structure. So that is nothing but a waveform, output waveform for the sinusoidal wave. Likewise, we have to calculate so this is nothing but a generalized shape. So generalized shape, if we are providing a constant amplitude, of A, or we can say when the unit step input is given, this value is nothing but A, or we can say this is value of X, whatever we take, that is A is nothing but a 1 volt, 2 volt, 3 volt, you may take any constant value, so that is nothing but a unit step value. Here we are assuming its value is 1, or we can say its value is A. This is nothing but a time axis. So if we are providing unit step as an input, so here we will get a spike like this. We are getting here a spike like this. Why? Because at t is equals to 0, it will take some time to reach from t is equal to 0 to amplitude A. So we know that differentiation of any constant value is 0. That is clear. Differentiation of any constant value is nothing but the 0. So differentiation of A, we know its value is 0. But to reach a zero value, to reach a value, it will take us some finite time. That's why it reaches to maximum value, that is negative value, because we know that the output of this differentiator is nothing but a negative, that is 180 phase shift. That's why we will get a negative pulse. So it will reach to the maximum negative, that is this is nothing but a minus A. We can say if we are taking amplitude RF into C1 is nothing but if we are assuming 1, so we will get here minus A. ठीक है, ये यहाँ पे मुझे माइनस A मिलेगा. Now after that what happened? Here we will get the minus A. Now after that it will reach the constant value A. So we have to assume this condition. For that we will get the 0 value. So after that we will get the 0 value. So from this it will reach to the 0 value. So it will take some time because of the capacitor. So it will take from minus A to 0 and we will get a constant 0. So this is nothing but the output of input when we provide the impulse as an input. So this is general discussion. So in next lecture we will discuss a next problem related to differentiator. So thank you very much.